Welcome to section 2 of unit 5. We're going to be doing lessons 3 and 4. We're going to be finding outputs from equations, so not just the input-output diagrams, but now equations, and then we're going to connect equations and graphs of functions. The first rule that we're going to work with is if we take S, the side length of a square, and we want to find the area of the square. How do we do that? Well, I've drawn a square off to the side here. Both side lengths are the same because it's a square, S and S. And I know that area is length times width, but in this case, my length and width are the same thing, and I'm calling them both S. So in my box here, I could write my equation as area equals S times S, or I could simplify that and just write area equals S squared. So now I can use that down in my table. If my input is 8, my output is going to be 8 times 8, or 8 squared, which equals 64. If my input is 2.2, my output is going to be 2.2 squared, or you guys finish the rest of this and then start again when you're ready. Okay, here's what the rest of the table would look like, and then to summarize it up, if my input is S, my output would be S squared. In lesson 3, activity 2, we're going to be completing this table working with functions. We're going to do the first column together, and then you will complete the last 3 on your own. So here we go. Match each of these descriptions with a diagram. A is going to match with diagram D. And that's because this is the equation for the circumference of a circle. Think back to last year in 7th grade. The equation then is going to be C equals 2 pi r, and I'm getting that from my input-output diagram here. If my input is 5, what's my output? Well, I'm going to plug in 5 for r, and I'm going to have 2 times pi times 5, and I'm just going to leave that as 10 pi. I don't need to multiply by 3.14. My independent variable, write this down. Independent variable is your input. So my input to my equation here is r. My dependent variable, write this down, is your output. And the output to this equation is C. So go ahead, fill in the rest of the table, and then check back when you're ready. All right, there's the rest of your table filled in. At this point, please ask questions of your neighbor or of Mrs. Gregerson if you're confused. Okay, in lesson 4, activity 2, we're looking at equations and graphs of functions. Now, this is a lot of stuff that we've already worked on in different parts of the year. But here we go. We're going to focus on graphs B and C for this activity. B is going to match with equation A, and I want you to actually write this equation up above here. It'll be easier to see. D is the distance in miles, and T is the hours that you drove. Graph C is going to match with equation B, and I want you to write this equation up here as well. Now, the big thing that you need to get out of this activity is how to label your axes. So going back to graph B, we have distance and we have hours. Now, looking at the equation, distance is your output, and that is going to be your dependent variable. Your dependent variable goes on the y-axis, and your independent variable goes on the x-axis. Same for the other equation. Dependent variable goes on the y-axis. Independent variable goes on the x-axis. So label that, and then you're good to go. Okay, lesson 4, activity 3. We are looking at Kieran running around a track. There's a graph here with a table down here. I am going to have you work through these questions on your own because I really believe that you can do these on your own. But one thing to keep in mind is that time is on the y-axis and distance is on the x-axis. We usually see that the other way around. So just pay attention to that, but answer these questions and then come back and check your work. All right, here's your answers for A, B, C, and D. Some of these are estimates, so if your answers are slightly different on C and D, that is okay. But hopefully you can notice from the graph and table where everything is happening. If you have questions on this, please ask a neighbor or ask myself. But going down to E, here's an important part. Is Kieran's time a function of the distance he has run? So basically, is this a function? And in short, yes, it is a function. And how do we know? Because for each input, there's only one output. You might want to write that down. For each input, there's only one output. In other words, Kieran can only be in one place at one time. He can only have traveled one distance after a certain amount of time. Now this graph has a little bit more going on, so we'll talk about this one a little more in depth. Priya is running around the track, once around the track. So I included a picture of a track over here to help you out. What is her farthest distance from her starting point? Well, if you're running around a track, it's 400 meters around. The farthest you're going to be from your starting point is when you are at 200 meters. So that's over here. And you'll see that on the graph. Here's 200 meters. And what was her farthest distance from her starting point? So it's going to be 200 meters. Estimate how long it took her to run around the track. So if she starts here, this is her time, how far she was from her starting point, and then she's getting closer to her starting point as she comes back around the track. So it took her about 74 seconds, we'll call that. Estimate when she was 100 meters from her starting point. That's going to be right here. We're in between 12 and 24, so that would be at about 18 seconds. Estimate how far she was from the starting line after 60 seconds. That's up here, 60 seconds. How far was she from the starting line? 75 meters. Now, if you think about the track, that means she's about here, headed to the finish. Is Priya's time a function of her distance from her starting point? This is a crucial question on this problem, and no, it is not a function. And it's because there are two possible outputs, for each input. And what I mean by that is that for each distance from the starting line, there were two possible times. So let's think about this one for a little bit. When she was 50 meters from the starting line, well, that happened about 10 seconds in, and it also happened at about 66 seconds in. So it happened twice. There's two possible outputs for that input. And so no, this is not a function.